Do you know anyone in the audience?
Once it gets up here, I'll be able to look.
Okay.
But they've been well attended so far.
Excellent.
All right, we'll give folks a minute or two here to get on board, and we'll get started.
All right.
So good afternoon, everybody. I'm Leslie Wolf with IN3 Tradewind, and I would like to introduce SitScape Incorporated. They will be doing the next presentation. So, all right, Kevin and Matt, go ahead and take it away.
Thank you, Leslie. Excuse me. This is Kevin Yin and Matt Rowe and Joe Marinage. We are representing SitScape here, and we have 20 minutes. So as we understanding is that since there's no Q&A, we're going to use the full 20 minutes, and maybe first 5 minutes or so, we're going to walk through a few PowerPoint slides very quick, just give a very high-level introduction. And after that, we'd like to just show some examples of the demonstrations with our product. And hopefully that will give you more of a intuitive way of understanding our offering here. So just first is SitScape. We are a US-based company headquartered in Virginia on Tyson's Corner. And we have various Fortune 500 customers, large corporations, and also Department of Defense customers ranging from Army, Navy, Air Force, DISA, and the various combat command. And we have also received awards and contracts and from intelligence communities such as NGA and NATO and others. And we also have U.S. patents for our advanced technology. The patent has been cited by Google, Microsoft, and many others, IBM, etc. Specifically on the DoD, which I think is today's audience here, we have been working with, for example, U.S. Navy on a number of large initiatives. This ranging from the global supply chain and the material management with LabC, and also the engine, which is the Navy engine for the global network monitoring, operational support, and the real-time analysis, and advanced analytics and the dashboarding and the common operating picture for the whole Navy networks, and the Air Force DCGS for global scheduling and the intelligence and mission support. This is all operational support with our technology. And we are a product company, and our technology has been used in this kind of environment in DISA and other places. Also in IC, right? So just a little bit related information on the customer that relate to today's audience. I know some of you are mostly from Navy, maybe, but some are from other DoD IC. So we have customers across the board. Right? Regarding specifically today's topics, our technology are very much general purpose, as you heard from large corporations in the commercial as well as the DoD. But related to today's topic, we would like to specifically highlight the three subjects, which are the risk monitoring and the forecasting, the course of action development, and the workflow management. And even though, for example, I understand the subjects such as logistics, warfighting, joint warfighting, because we provide a common operating picture and advanced analytics powered by AI, machine learning, and risk monitoring, we technically address broader than that. Because of the time limitation we have today, we're going to focus primarily on the risk monitoring and the forecasting and the course of action, and with some workflow support. And with that understanding is our technology are low code based, which means there's no coding involved in any of those efforts when you're developing visualization, correlation, analytics, advanced machine learning, modeling, and algorithm development, and the risk calculation, and root cause analysis, and the process automation, workflow management, and all those combined together. And there's no coding involved. or drag and drop and automate it for you. So I'm going to show you a few screenshots first, then just show some examples and the live demonstration, right? With that said, just a few example screenshots here. As you can see, this is our core backend process automation AI pipeline product. We call them SDP, straight through processing. It's basically a drag and drop environment for you to do data processing, ingestion, automation, analysis, and also integration across many different data sources. This it runs automatically as a robotic automation behind the scene with no human involved. Once you run that, it's be tie into different machine learning models and algorithms, as you can see here, and run the predictions behind the scene to power the automation with the processes. And it can also generate visualization on the fly for monitoring, correlation, alerts, and drill downs and course of action, and the geospatial visualization and the dashboarding. And they can also generating customizable user interface for application. So more than just the traditional dashboard or common object picture, it can also be highly customizable user interfaces. And just keep in mind, I'm not doing all of those with no coding. And that's one of the reasons our technology has been used very rapidly across the board. It's because the productivity, the agility, and the extensibility of the technology has been proven that's at least 10 times, if not 50 times or more, more productive than some of the conventional way of doing this, end to end, from the data ingestion, correlation, transformation, analytics, machine learning, to the large scale parallel processing and the visualization and application enablement, all happening in a single platform. This technology has been battle tested, as I mentioned before, in the DoD in the operation environment in a very large scale. And we are currently under contract supporting some of the global initiatives right now. So before getting into too much details in the PowerPoint, I like to just go straight to show some examples and to see how the technology can be used. Specifically, as I mentioned, some of the risk monitoring and the forecasting and root cause analysis and the course of action analysis and the driving by this kind of back-end and the front-end technology together. So with that said, I'm going to drag them over here and to show you a few examples here. So this is a specific example, which is the work we did with the U.S. Army with the cyber, is to analyzing all the various data sources and in real time analyzing the risk position and profile of the Army network and Army missions, and be able to calculating and risk and root cause of risk on the fly based on consolidation and analysis data from many different sources. And one of the key concepts here is something we call them decision or root cause driver tree. That basically the concept is pretty much everything is a effect and a cause. If you can model that, and you'll be able to decide what's the impact of some of the risk. And this is the example of that. So let's take a look a live example here. So this live example, as you can see, that it shows you various of our Army underlying technology driving an impact to the high level of systems or missions or dependencies like this. And all those will be connecting many, many data sources, and then they're going to drive a very large decision tree and a driver tree. And those will each part of the network and the decision, we apply various algorithms and machine learnings calculating the risk. And if you do that, you will be able to continue to drive all of those and calculate the risk at every stages of your network. And specifically, look at this one. You can see that this is a cluster analysis on overlaid on the map environment. So you can see that this is see everything, seeing what's going on, and at every single point of time, those data basically connected, analyzed, and decided at real time across the board, apply the machine learning to drive a risk profile at every part of the enterprise or the network. And this is a fairly complex stuff, so I'm going to only show you a few examples here. And let's take a look at the other one here. You are able to see, various of, dependencies and the network relationships and all the stuff that's driving by the profile analysis that's cost, impacted by various of the drivers of the risk. And this is a general purpose product, so it's not specifically for the network or cyber. I'm using cyber here as an example, but it's really applying to financial, compliance, or mission, other dependencies, anything involving dependencies or effect and the complex networks. This is a viable technology for you to do that. So this can be applied on the maps, and be able to see information overlaid, geographically, financially, from all time, tempo-based information overlaid on different ways of looking the data sets, and that's across the board. The data sets, as I said, doesn't have to be cyber data, right? So it just can be network data or even financial data, transaction data, anything like that. So just give a little bit idea on regarding, in this specific example, how this driver tree look like, and you can see that. And I'd like to bring up a PowerPoint just to illustrate the concept a little more, so that we would know what this really means. So if you can see that this is a root cause analysis tree that actually has an issue in the cost, and our job is actually analyzing and creating all those kind of dependencies based on data analysis and data correlation, and it runs machine learning across every single part of the processing, and ultimately put a more holistic profile understanding of the risk, and be able to run the modeling and run the forecasting on the interesting of the data sets, and further create a course of action and predictions for that. This is fairly advanced stuff here, and I'd like to show you some little more visualization of this on top of that. So with that said, I'd like to show you a little more visual stuff there here. You can see in this specific example, I have a driver tree that's risk on decision, and I'm able to calculate all the risk here. And from the algorithm perspective, as you can see that I have a machine learning or other plug and play analytics module to drive this analysis. So if just a simulating example of this is, if you're simulating here, that's with a risk profile of say 90, and you can see that the whole network turned into red because of the analysis was calculating recursively for the risk of this. For example, if a disk fail or fail the user login, something like that. This is just a fairly simple example of illustrating that. And if you take this to automation, and it will become really interesting on that. So just take a look at that stuff. If I click on one of those guys here, just here. So if you look at this guy, I'm analyzing the large scale, the networks, and be able to scanning my environment and automatically tell me what's going on. So I'm going to run this guy here.
Activity view, application view, support view, tickets view, support tickets view, heat map view, CPU timeline view, workload view, CPU utilization spiked here. Highlight the issue.
You can see the system does automatic analysis.
Drill down the analysis.
During the analysis, and actually drill down, tell you where the problem, pinpoint the risk, and tell you where, in the dashboard, and allow you to see exactly what's happening, by, intelligently generating and pinpoint highlighting the risk and the root cause from a very high level down to the low level. And if you combine this concept into the more of a sort of a navigation view, this becomes something like this. You see it like this. So you can able to zoom in and see something like this, and seeing part of this. So you bring the physical and the digital world together, and to be able to do all of this very, very quickly, and seeing something happening here. And this is tied to the free, more of a user-friendly front end to a more powerful automation with analytic back end, and to deliver the experience to you and easy to understand that way. And but they're powered by the analysis of all the data sets you have, and be able to allow you to so further pinpoint what's going on here. You can see that I'm actually analyzing as a human, in the loop if necessary, in addition to machine generating the insights for me, as so it become a very powerful machine and the human collaboration of this, and allow me to see information specifically that's more relevant to what I was care about. And this can be used for analyzing, for example, the various data sources allow you to highlighting through visualization where the risk is, and allow you to further pinpoint on that stuff like that, right? So this hopefully give you a little bit idea about some of the stuff I was talking about, from the driver tree to the risk analysis to the visualization and to the human interactions and interventions. There's obviously a lot more. With a limited time, we're not going to go through too much detail here. And with a little bit more time here, and lastly, we have another 4 minutes. Is that correct? So if not, I think we should have 4 minutes here. So just maybe take that time to illustrating more of a Navy's related subject here. Is because I know some of you folks are very interested in logistics, supply chain risk management. So we are currently working with U.S. Navy NAVSEA under a contract to modernize and transform all the material supply, material management of the old Navy ships using our technology, which is called ship maintenance material systems. And this will basically modernize and digital transform them into a new generation of technology to power the supply chain material management using SitScape technology. And this is just an example of that. And this allows you to do purchasing, sourcing, receiving, warehouse management, inventory management, issuing material to the carriers and the ships and submarines, and managing the shop stores, and various of other business process automation and analytics, for example, here. So you are able to see various of information under the visualizations and the materials there. And you can see all the materials that across the board of the Navy and all the ships. And by the way, the data are just not real data, they're demonstrations. So hopefully that gives you a little bit idea on that. I think I got 2 minutes, so let me just summarize what we just talked about so far, right? So we are able to connecting to various of data sources and using a data-driven strategy by automating AI and machine learning powered automation pipelines. The pipelines here, I talk about here, and they use that to derive analysis and insight about risk, then generating visualizations that are highly interactive and friendly, and also intact for user to further drill down to understand the insights and better course of actions. And they are highly automated for you, and driving by the decision tree and the root cause analysis, in this case for the risk analysis, that's a highly repeatable and explainable, in addition to automated, right? And this is the user interface. We don't have time to show the details. How do you actually run and model the analysis? and the algorithms and be able to drive this. There's no single line of code you have to write. You just basically plug and play. If you have a machine learning model, you can plug your machine learning model into our environment. But all the rest of the pipeline and analysis are still reusable without the coding. And ultimately, you basically drive this kind of decision-making process from identify the problem, root cause, and solution, and the course of action decision. And that's